All right, here we go. This is Mr. Bishop back with you, spinning the globe right there. Today we are talking about applications of matrix multiplication. And this is Chapter 2, Day 3. Previously we talked about how to multiply matrices, whether by hand or by calculator. So some things we know so far. We know about matrices in general, right? We know that there are ways to store and organize information, specifically numbers, and we know when it's okay to multiply them together, right? We just have to check their dimensions. So dimensions for matrices are RC, rows by columns. And we learned that in a previous video too. So if we're looking at two matrices, we want to know whether we can multiply them together. We compare their dimensions side by side here. So if I'm doing matrix A times matrix B, I look at the inside numbers, and those have to match. If those match, then I can move forward with matrix multiplication. In my new matrix, the offspring of these two, if you will, it will be the size of whatever the outside numbers are. So those outside numbers will tell us the dimensions of our new matrix. So again, that's just to refresh you. Also, we know when it comes down to actually multiplying these things together, we multiply each row in the first matrix times the corresponding column in the second matrix. And then we add up the results for each of those to get our new matrix entries. And then most recently in the video right before this, we learned that you can also do it on the calculator, right? And especially for bigger matrices, that's going to be way more efficient for us. And you can go back and watch that video to learn how to do it on the calculator, but it pretty much comes down to you hit the second matrix button, right? It's right above this little X with a -1 on it. So if you're not familiar with that, go back and watch that last video so you can learn how to multiply matrices on your calculator. It might save you a lot of time and heartache, especially with bigger matrices. So let's go ahead and start by taking a look at the Day 3 worksheet. This is the first problem on the worksheet here about wardrobe costs. I mentioned that matrices are ways for us to store information, specifically numerical values. They're most often used with technology like computers or calculators, for example. So we're going to start it off nice and easy by looking at a simple example about wardrobe costs. It says the quantities of pants, shirts, and jackets owned by Mike and Don are given by the matrix A. So there you go, matrix A. Lovely little labels here, Mike, Don, and then pants, shirts, and jackets. The costs of these items are given by matrix B. There you go, pants, shirts, and jackets, and then the cost for each. Part A just says calculate the matrix AB. So that means multiply A times B. What is their product? So I'm going to go ahead and write down again matrix A with the labels here. Got Mike and Don, and then you got the pants, the shirts, and the jackets. There we go. And then matrix B, I'm going to write that one down again. So I've got the prices for each pants, shirts, and jackets. And so the first question is, can we even multiply these together? Is it legal, or will the math police be involved? So we compared the dimensions here. Matrix A is a 2 by 3, right? 2 rows by 3 vertical columns. And matrix B is a 3 by 1. It's got 3 rows and 1 vertical column. So we start by comparing the inside numbers. It looks like, yes, we have a match, so we can move forward. And our new matrix, the offspring, will be we'll look at the outside numbers, a 2 by 1. So I'm going to go ahead and make that and just kind of leave a blank here. I know it's going to have 2 rows and 1 column. So that's the first order of business. Yes, these can be multiplied, but only in this order, by the way, right? If we were to switch the orders, I don't think it would have looked as good for us. So let's go ahead and start with the first entry here. I'm going to kind of color code it. The first row for Mike times our only column over here, the prices for each. Multiply each corresponding entry, and then we add it up. We get 280. again, if you'd like to do it on the calculator, you can do that too. And then let's go to the second row there for Don and multiply his values times those prices. Add them all up, and we are looking at 175. Beautiful. There we go. We've calculated the product, matrix A times matrix B. Part B just says, interpret the entries of matrix AB. That means explain what they represent. Because it says, what is the meaning of the result of your calculation? And to get these numbers, we multiplied the rows in matrix A, which would be Mike's quantities for his wardrobe and Don's quantities for his wardrobe, times the prices for each clothing item. So now it's our responsibility to explain what these numbers represent. Well, the general gist, right, my little side note for you here, the matrix AB that we just calculated tells us how much each person spent on clothing. So if I had to go ahead and label the columns and rows here, we know this would be, remember we got the rows from matrix A, Mike on top, and then Don comes second, and then the price, right, because this was the columns for matrix B, that's how much each person spent on clothing. So we know that Mike spent $280 on his wardrobe, right? Mike is $280, and Don spent $175 on his wardrobe. Okay, so there you have it. That's kind of an easy example, right, with only 2 people and only 3 different kinds of items. But you can imagine if we applied that across thousands of people, right, and a whole lot more different wardrobe items, right, we would need a computer or a calculator to help us do that. Okay, and there's one more problem I'd like to look at with you. Number 69, the one about course grades. It says 3 professors teaching the same course have entirely different grading policies, wouldn't you know it? The percentage of students given each grade by the professors is summarized in the following matrix. Looks like it's this matrix right here. So you've got Professor 1, Professor 2, Professor 3, and then the percentage of grades they give out across A, B, C, D, and F for each person. Right away, I think Professor 3 might be the hardest grader, just judging by the grades. In fact, it looks like 25% of the students in Professor 3's class fail, which is not good, especially compared to like Professor 1, for example. So part A here, it says the grade point values of the grades are A equals 4, B equals 3, C equals 2, and so on. So that's how your GPA is calculated. An A is worth 4 points. That's how you get a grade point average. A B is worth 3 points. A C is worth 2 points, and so on. It says create a 5x1 matrix representing the grade point values and use matrix multiplication to compute grade point averages for each professor. Show your work. So a 5x1 matrix, that means 5 rows by 1 column. So I went ahead and made this skinny looking matrix here because it's only got 1 column. And we know it's the grade points that go in here, right? So an A is worth 4, a B is worth 3, C is worth 2, D is worth 1, and F is worth 0 grade points. So there's our cute little 5x1 matrix for how much points each letter grade is worth. And so now we're supposed to use matrix multiplication to calculate the GPA, the grade point average, for each professor. So I'm going to go ahead and copy down this matrix again because that's going to be our first matrix. So I got Professor 1. He's got good grades across the board for the most part. Professor 2, not quite as good, but okay. And then Professor 3 seems to be a rough grader for sure. So there's the matrix for my professors and their distribution of grades, right? Times the little 5x1 matrix I just came up with. So I'm going to go ahead and copy and paste that here. And it's important that you get the order correct here, because if you switch the order, I don't think this multiplication would work. The professor matrix is a 3x5, 3 horizontal rows by 5 columns. And our GPA matrix is a 5x1, right? So right now, if you do this matrix times this matrix in order, the inside numbers match and we'll be okay. But if you switch that, we'd be in trouble. Okay, so the new matrix is going to be a 3x1. It's the outside numbers that tell you. It's going to be a 3x1. And when we multiply here to get that matrix, we're going to start by, if I color code here in gold, the first entry is going to be row 1 for Professor 1 times the grade points, and then you add those up for each, we get 2.75 for the first entry. And let's go to Professor 2 there for our second entry, if I can color code in gray. Professor 2, grade distribution times the points, and then add those up, we get 2.0. And last but not least, well, probably is least in this case, Professor 3, a rough grader indeed. In blue here, take Professor 3's row times the grade points, add all those up. We were looking at 1.3, the GPA for Professor 3's class. And let's go ahead and label these two. We got Professor 1, Professor 2, Professor 3. And this would be the GPA, the grade point average for their individual classes. All right, so we weren't asked to interpret here, but we oftentimes are. If you had to interpret this, you'd say this matrix shows the GPA for each individual professor's course. All right, that is your introduction to actually using matrix multiplication in some real-world applications. That is all for these notes. Thanks for watching.